Coding guidelines are the following. You should use always FF, the flip-flop version, and non-blocking assignments. The non-blocking assignments are the one that basically is like that, okay? This is the non-blocking assignment, sorry, like this, okay? The non-blocking assignments, you should always use them, or what we call deferred assignments, for registers. If we're dealing technically with sequential circuits. So if you're dealing with sequential circuits, registers, counters, and whatnot, you use always FF and non-blocking assignments. If you are dealing with combinational circuits, you use always comb, which is combination, and you use blocking or immediate assignments, okay? So these are the two rules of thumbs. Even though you might not understand how non-blocking and blocking assignment work, which you should watch the video that explains the differences and how they work, if you use these two guidelines, you should be fine and your code would work almost always all the time. The last two, you're going to see that the third one says assign a variable only in a single always block. I'll explain this with an example shortly. And separate member components, registers, into individual code assignment. This is more stylistic, and we'll talk more about it when we talk about sequential circuits. It's related to registers and counters when you use always statements with. So let me explain why you need to assign a variable only in a single always block. So what I'm going to do is I'm going to explain it with a very short example, okay? We'll talk about this later. Okay, so let me explain this here with an example. So the example says, there's a module and it's called race, and I want you to pause the video for a minute or two and just think and tell me what is the output y at the very end of this module in here. Okay, that's what I want you to do. Just pause and see it. Okay, so you hopefully had some chance to actually think about it. And you can see here what I did is I used always com. That means I'm dealing with the combinational circuits, and I have an always com and I'm dealing with the combinational circuits. Yeah, we have not seen if yet. We're going to see it shortly, but you know how if works. So this tells me if clear, y should be this, and if it's not clear, y should be that. Okay, so, well, technically speaking, the value of y depends on the value of clear. Whatever clear happens to be in y will be changed accordingly, okay? And that's basically it. So you can think about it and tell me, well, if clear is set to 1, chances are y would be this particular value. Okay, that's fine. That's absolutely fine. It's good. All right. If, well, on the opposite side, if let's say clear happened to be 0, that means this is the one that is true. That means y would be this particular value, which is 1 bit 1. Basically, y would be 1. Okay, that's fair. So now let me just think about it this way, and I'm gonna ask you to do the same exact exercises, but now. Okay. That's what I'm gonna actually ask you to do now. So we'll pause for a minute and now think, basically answer, what should y be at the very end of this code? Okay, pause for a minute and think about it. Okay, so hopefully you got the chance to think about it. And you can see here, it's basically y. It's kind of strange. So y would be a plus b or y would be a minus b. It's basically both at the same time. And it cannot happen. So whatever a is, whatever b is, I'm just basically adding them up or subtracting them depending on which always statement gets implemented first. If you thought that, well, the y minus a minus b comes last, so y should have this value, you're wrong, because what happens in here, I want you to think about it this way. Let me highlight it. So this part in here, you can think about it as a circuit, and this part here is a separate circuit, okay? They're completely separate circuits, and as you know, Verilog and System Verilog are basically concurrent languages, and these two circuits are operating concurrently. Yes, I have two always statements, but always statements are not sequential. What I'm saying is if you flip the green and the red, your code is gonna do the same exact thing. It's exactly the same. So this is what we call a race condition, because y is being assigned in a couple of always blocks. So if a changes, both always, if the value of a changes, both always blocks will be activated, and both of them are trying to change y, and that causes a race condition because you don't know what the value of y is. And syntactically speaking, this might have been very clear in here when I explained it. and it looks very logical. However, it has the same exact problem. And this problem is the first always statement here is actually a circuit element, and this one here is another circuit element. Let me highlight them in different colors so you guys can get to see it. So this is a circuit element, and this is another circuit element. And both circuit elements are actually trying to change Y. So you are trying to change one item or one bit using two different circuit elements. It's exactly the same as saying, well, I have a gate in here and I'm going to connect it to Y, and I have another gate in here which is OR, and I'm going to connect it to Y. It is the same exact thing. It's wrong. You should not be doing this. So generally speaking, the third rule of thumb here, it says assign a variable only in a single always block, which means that if you are assigning to Y, you should not assign it in separate always statements. You should always keep it within one always statement. This is very simple to do in this case because you can combine this if statement in a single always combinational, and that's about it. The same goes in here, and here it's a little bit more complicated because if you put Y equals A plus B, Y equals A minus B in the same always statements, the order of the statements actually matters at that point. This again is what we call a race condition, and in order to avoid it, only assign a variable once. Do not assign it several times. Or you can assign it several times, but within a single always statement. Don't assign it in different always statements.